Welcome to my YouTube channel. In this video, we will discuss complete information about the capacitor, its capacitance, and its symbols, specifications, stray inductance, and also we will discuss the factors that affect in the capacitance of a capacitor. Before going to begin the video, please do subscribe to my YouTube channel and make sure to like, share, and do comment with your questions or suggestions. Let's start with capacitor. See, a capacitor is a passive component that stores energy in the form of electric field between the two plates. See the symbol of the capacitor. There is a two parallel plates. In between the two parallel plates only, the capacitor will store the energy or charge in between the two parallel plates in the form of electric field. The charge is stored in the form of potential difference between the two plates, that is maybe from positive to negative, and in between the two plates one non-conducting region is present in between the two plates. That non-conducting region is called dielectric. The dielectric medium material may be either air, mica, ceramic, aluminum, etc. Means there is a non-conducting region in between the two plates. That non-conducting region is called dielectric medium. Dielectric material that can be either mica, ceramic, etc. And here you can see the symbol of the capacitor, and this is the real image of capacitor. And the right side of the slide there is a different types of capacitors that capacitors you can see in your laboratories also. Now capacitance. Capacitance is the ability of a capacitor to store electric charge per unit potential difference. Means in capacitor, what is meant by capacitor? It is a passive component that will store energy in between the two plates in the form of electric field. Now coming to capacitance, it is the ability of a capacitor. Means how much energy or charge will be stored per unit potential difference is known as the capacitance. This capacitor consisting of the two conducting plates. The two conducting plates are separated by the non-conducting region. That non-conducting region is called dielectric. Dielectric material that may be insulated. That insulator like mica, ceramic are filled in that non-conducting region. And this capacitor is measured in terms of farads. In mathematically, we can tell that ratio of charge of a capacitor plates to the potential difference across the plates. Now see the diagram. Through this diagram you can get the clarity. So there is a capacitor and there is a lead, that is positive or negative, and there is a two plates. That plates are called conducting plates, and in between that two plates there is a non-conducting region. That non-conducting region is called dielectric. In that non-conducting region only we can fill dielectric material like ceramic, mica, paper, aluminum, etc. Now see the diagram. One battery is connected to the capacitor. See, when some amount of voltage is given to the capacitor, it will start charging. And this is about capacitance. Now we will see the classifications of the capacitor. See, these capacitors are classified into different types based upon the various functions. According to the physical construction, these capacitors are classified into two types, that is fixed capacitor and variable capacitor. Fixed capacitor means the capacitance value cannot be varied. Means that capacitance value is constant. Examples for the fixed capacitors are paper, mica, ceramic, electrolyte, etc. And variable capacitor means the capacitance value may be varied. That examples for the varied capacitor is tuning capacitor and dimming capacitor. Here you can see the real images and circuit symbols of fixed and variable capacitors. Capacitors are classified according to the dielectric medium. Dielectric materials like paper, glass, ceramic, mica, polyester and electrolyte. Here you can see the real images of these all dielectric materials of capacitors. According to the polarization, these capacitors are classified into two types. They are polarized capacitors and non-polarized capacitors. Polarized means there is a particular symbols like one terminal has positive and another terminal has negative. Non-polarized means there is no particular symbols for that capacitor. That capacitor is known as the non-polarized capacitors. These polarized capacitors are mainly used in the DC applications. Non-polarized capacitors are mainly used in the AC applications like mica ceramic. Here you can see the clearly difference between the polarized and non-polarized capacitors, and its symbols also given here. According to the voltage rating, they are low voltage capacitors and high voltage capacitor. The capacitor which has less than 50 volts, we can consider that capacitor as low voltage capacitors. Examples for the low voltage capacitors are ceramic, electrolyte capacitors, etc. And coming to high voltage capacitors, a capacitor which has greater than 100 volts, that capacitor we can consider as high voltage capacitors. Examples for the high voltage capacitors like mica, glass, ceramic capacitors. These comes under the high voltage capacitors, and it is classified according to the shape. Disc capacitors and tabular capacitors. You can see the images of disc and tubular capacitors here. And our next topic is circuit symbols of fixed and the variable capacitors. See here there are the different types of capacitors, circuit symbols. We can observe that very clearly. The specifications of the capacitor are tolerance, voltage rating, temperature coefficient, dielectric constant and dielectric strength, capacitance value, power factor, stability. These are the main specifications of the capacitors. Next topic is stray inductance. Stray inductance is defined as unwanted capacitance existing in between any two conducting supports by a insulator. See, there is a capacitor. When the capacitor is in the on state, there is some unwanted capacitance. That unwanted capacitance is called stray capacitance. So these stray capacitance magnitude is usually very small, and that is less than 1 picofarad, and that have negligible effect on the DC low frequency AC circuits. Here there is a small diagram to understand the stray capacitance clearly. So to reduce these unwanted capacitance means stray capacitance. To reduce these stray capacitance, there is some methods like connecting wires and leads of electronic components. By using these methods, we can control the stray capacitance. Now we will see the factors that affect in the capacitance. First one is area of the plates. The area of the plates is directly proportional to the capacitance. Means if area of the plates is more, then the capacitance means energy storage is also high. If area of the plates is less, means storage of capacitance is less. Second point is distance between plates. The distance and the storage capacitance is inversely proportional. If distance is more in between the plates, then the capacitance is less, or vice versa. And third is permittivity of the medium. And final topic is applications of capacitors. So where these capacitors are applicable means low DC power supplies, noise filters, high pass filter, tuning circuits, coupling and decoupling, communication circuits, motors, and consumer electronics. Before going to close the video, please don't forget to subscribe my YouTube channel and make sure to share, like, and comment with your questions or suggestions. Thank you for watching.